I'm David Sugg. I'm the Vice President of Content Architecture and Engineering for Warner Brothers. So I look after a variety of different content-related systems and processes and media engineering activities for the studio. So just real quickly, in case there was three people in the room that don't know who Warner Brothers is. Today, WB is performing at the top of our game. We're leading in major areas of entertainment. We're setting records at the box office with recent hits like Crazy Rich Asians. We've been the number one TV studio for the last 9 seasons. We've also built an amazing gaming company through acquisition over the last several years that's generating more than $1 billion in revenue just last year. So it's a big thing for us. It's also home. WB's also home to some of the world's biggest brands, including my personal favorite, Harry Potter. It's one of those things I read to my kids when they were growing up. It's a great brand. We've also got DC Comics, the Wizarding World, Middle-earth Family, among others that you see on the slide. So we're going to talk a little bit about the 100-year challenge and what that means to us, to the studios. So for many companies, the data they create supports their business and the creation of their products. For example, an automotive manufacturing company. For other companies, it can be argued that that most of the data they create is their business, but it's not their product. For content creation companies, the data we create is our business and it is our product. And so for that reason, we tend to think in the terms of preserving things for 100 years or more. And that's an interesting problem. We know how to make film in cans exist or last or work for over 100 years. It's a well understood process that's both tested as well as reality has proven that it works. Unfortunately, nobody really knows how to make digital collections of digital bits last that long, and more importantly, last that long in a predictable and low effort manner. Right? We can all stand around and migrate LTO 5 to 6 and 6 to 7 and 7 for the rest of our natural lives, but it doesn't really sound like a great time. So what we really need is the Superman Fortress of Solitude knowledge crystal. If you know anybody that has one of those, let us know. So while preserving those bits for all eternity is certainly the top of mind, it's not really the only consideration for us. We, like many companies, categorize threats to our assets, and we think about things like bit rot and media failure and EM pulses and loss of tribal knowledge and disease and war and zombies, and it just kind of goes on. Do
you have zombies on that spreadsheet? If you do, I want to see it.
If you can read that little tiny spreadsheet behind, then maybe it's on there. But we are an entertainment company, so you got to figure there's zombies in there somewhere, right?
Eat your own dog.
And if not, I'm sure that Brad and I can make sure that they get added. Okay. So each of those things are assessed by against probability and impact, and then they're solutioned for. So. But digital content archives have a special problem in that it is important to ensure that all the bits are always present and that we're able to repair or replace them if they're damaged or missing very quickly. Technology such as remote replication can overwrite good files with bad if they're not managed properly. Excuse me. This insurance of bit status is called Fixity. Mike mentioned it a second ago. And preservation technologists are, fixated on it.
It's true.
It's true, among other problems. Fixity helps us solve for threats like media failure and bit rot. It also gives us a good understanding of the state of our assets at any given time. Fixity can be managed via checksums, and it usually is, and can be applied at ingest if the fixity is known for the file. So if I know what the checksum for the file is when I get it, I can ingest and check against, right? I can also manage it throughout the life cycle by running regular checksum checks, and I can also do it during any event, like a file copy or a file move. So this is an interesting quote. I'm going to read this just because I think it explains the concept well. It's from there actually is such a thing. If you're not a preservationist, now you know. The Digital Preservation Handbook, as presented by the Digital Preservation Coalition. Fixity doesn't just apply to files, but to any digital object that has a series of bits inside it, where that bit stream needs to be kept intact, with the knowledge that it hasn't changed. Fixity could be applied to images or video inside an audiovisual object, to individual files within a zip, to metadata inside an XML structure, to records in a database, or to objects in an object store. So this is Fixity. Right? You learn more about Fixity than you ever thought you wanted to know. So every bit's important, and it's not enough to just have 11 nines. You know, Amazon and AWS and others like to talk about the number of nines they can give us of durability, right? That's not enough. Those bits have to be kept safe. Even losing one bit in a file is a problem, because once they're gone, there's nothing we can do about it. So our current standards require us to check Fixity on a regular basis. So that can be monthly, it can be quarterly. It's certainly more than at least once a year, right? Oftentimes more than that. So there's an interesting problem is that cloud providers like AWS provide tools for checking Fixity at time of file upload, file download. And Fixity inside their infrastructure, it turns out, is verified regularly by the tooling that they provide. But there's no way for me to access that data today. There's no way for me to know. And so when you're talking with a preservationist that wants to understand the state of their asset archive, they want to understand what the Fixity status for a given asset is across the thing. When was it checked the last time? What type of check was performed? What was the status? What happened if there was a problem? That's what they want to know. So AWS and other cloud providers have features in their feature requests in their pipeline to add that sort of visibility to that Fixity information, which we want to then incorporate into our archive to help us manage that asset through its 100+ year life cycle. And it turns out it's important to other folks that are really trying to manage that for that really long-term thing. And so this data is really, really important for any serious digital archive, because the alternative is to deploy separate compute processes to validate Fixity, and that's expensive. I got to roll compute. I got to read every bit. I have to rehydrate every bit off of Glacier or Deep Archive. I have to read those bits. I have to checksum them, and then I have to trunk them and move on. And that's really just improbable from a cost perspective across a multi-petabyte archive. So, how do we manage this today? Right now, we've got redundant, geographically dispersed colocation sites, so we're fully terrestrial. Think of Ek Chong's diagram. It's similar, SL8500 tape libraries. A mix of T10K and LTO tapes. We perform monthly, quarterly, and biannual Fixity checks of every bit in those tape libraries. If we find a bad bit, we replace from a good copy, and we retire that tape. That tape goes away. It's gone. We also age tapes out. So the tapes don't exist in the library longer than a certain period of time. It's defined by our understanding over the course of the years of the aging cycle of LTO tapes. They don't last forever. Typically, we're pulling stuff out at least every 3 years. So a tape is literally just copied off and erased, even if it's still good, every 3 years. And as you might expect, the usual challenges are addressed by moving to the cloud. So the usual challenges exist as well, and Ek Chong talked about this as well. In particular, there's real costs for things like egress and storage, but there's also those perceived costs, costs of compute, the visible versus the hidden cost. I'm sure many of us have been in those conversations about how the tape library is free because it's a sunk capital cost, and there's real costs for me to run compute and pay for storage every month. And so there's some real issues with that. And there's perpetually in our industry, though it's getting better and better and better, is the question of security. How secure is it, right? And each of those issues can be managed.
Can you
cost
click
one.
forward,
I'm sorry,
one?
huh?
Can you click forward one? I think you're on the.
Nope.
Oh, okay, good. Just
Oh,
wanted to make sure.
no, you're right, I am, sorry. Thank you. Realistic TCO calculations are really important, right? So making sure that you're actually looking at the total cost of ownership for that archive. We are in a particular scenario right now where parts of our archive are actually managed by a vendor, and so that makes it even a step more obscure to us what the actual TCO is on the actual library itself. Another thing that's been really interesting to watch inside of a 100-year-old company is the updating of the accounting methods, right? So in very old companies, managing sort of monthly cost and OpEx against managing capital spend that's seen as a very sort of free money versus not is a real big problem. So the finance folks have been working pretty diligently inside of our organization to get much better at that, and they've made some big strides. And while security issues are real, those of us that are working to move stuff into the public cloud know that they can be addressed with smart policies and smart implementation. The cloud is really great for getting stuff done really quickly. It's also really great for doing stupid things really quickly, so you can fail really fast in a pretty amazing way if you don't do things smartly. So, what does it look like for us today? This is a really high-level view of what we're doing now. So we've got lots of vendors that are sending content into our archive. Companies like, most studios in general, use a lot of outsourced vendors for this kind of thing, for the sort of preparation of content for archive. And that comes in through an ingest process, and then there's a replication that's managed both at the storage level as well as at the DAM level. And that's actually a complex process. It's actually pretty tough to get and keep right. But the real killers here are the lack of elasticity and the long enhancement cycles. Both classic public cloud advantages, right? It's simply really, really difficult to scale up or down. It just is. I got a big storage setup. I got a bunch of tape libraries. I need more storage. I need more tape libraries. That's a long cycle for me to get through. Classic sort of cloud arguments, right? So this is what makes the move to cloud so compelling. So we've been working on a cloud-based solution, and this is a variation of what this might be iteration 376. That we're working on delivering. We're actually, as Mike said, we're sort of mid-flight on this journey. Our preservation policies strongly encourage, I'll use those words purposely, strongly encourage vendor diversity, right? They really want us to be vendor diverse. And it makes sense. So we're likely to replicate a copy somewhere else, somewhere besides AWS, but that's represented on this diagram by colo-location 1. That said, it could be a terrestrial facility, might be. It could be another cloud, or could, depending on the scenario, might just be another region within AWS. It's still being discussed with our preservation folks. The replication strategy is still being designed, but you'll notice in front of this stack there's actually a services layer that we're building that's actually standardizing a lot of our processes for intake and output. 1 second. It's going to be an interesting exercise because part of our design ethic has us actually removing the DAM, or moving this up above the DAM, the replication strategy, not having it be a DAM-driven strategy. There's a lot of reasons for that. Some of them are relatively clear, sort of getting to a scenario where we've created services that are decoupled is compelling for us, and sort of pulling things out of a monolithic DAM application is very interesting to us. We'll certainly manage our elasticity concerns in this scenario with using cloud resources. So that means the intake comes in through the cloud, that we burst up, slow down, whatever we need to do. Egress is certainly a concern in this model, but there's lots of tools to help us manage that and understand and deal with those costs, direct connects, and other tools that are available. Details on this are still being hammered out, as you can tell, but we're really excited about making this change and getting this thing up in the cloud so that we can start doing a lot of the stuff that Ike Chung laid out in the last slide of his deck. I think all of us are trying to figure out how to better leverage our assets. And this is a big step for us to get to that place.